Okay guys, so we started in class on solving quadratics by factoring. Okay, so this is what this is going to be about for homework as well. And what you're going to learn is how to solve quadratics by factoring when the a is not equal to 1 now. So we talked about it when a is equal to 1. Now we're going to talk about when a is not equal to 1. So let's go over some key vocab. And guys, make sure you do the vocab words. So factoring is a method to solve quadratics. And if you're going to factor the quadratic, you have to always set it equal to 0. And we'll go over that. Sum means the the result of adding. A quadratic is written like this. This is the standard form for a quadratic. Quadratic equation is when you have some type of quadratic written in standard form equals something, and we want them to equal 0 so we can solve them. The factoring method, we're going to use the X box, and it's, oh wait, I need to go back over what a factor is. The factoring method is a method used to solve quadratics. Okay, I need to go back over the other word. What's a factor? So I'm sorry. So a factor is two numbers that multiply to equal another number. Okay, so here's what I mean by that. Here's an example. So what are the factors of 4? The factors of 4 are 4, 1, 2, and 2. So these are the factors of 4. Next, what are the factors of 20? Let's do the factors of 10. So the factors of 10 would be 1, 10, 5, and 2. These are numbers that I can multiply. 1 times 10 gives me 10, 5 times 2 gives me 10, 2 times 5 gives me 10, and so on in that manner. And you can keep that going. So it's the numbers that break up, two numbers that multiply to give you a number, and we're going to need those when we factor these quadratics. Okay, so let's talk about the greatest common factors, and it's the biggest factor that a group or a set of numbers have in common. For an example, if I do 3, 6, and 9, the greatest common factor, that 3, 6, and 9, and we call that GCF. The greatest common factor 3, 6, and 9 is 3. And if I break this down, I get 3 times 1, 3 times 2, and 3 times 3. They all share the number 3. That's the biggest number, or the biggest factor they all have. I'm going to do another one. Let's do 24. Let's do 12, and let's do 6. So here I get 6 times 4. I also can get factors there, 12 times 2. We can do 8 times 3. And then 12, you can get 6 times 2, 4 times 3. Hold on, let me write this in here. Let's try that again. So these are a little bigger. So I'm going to say 24 in one box, 6 in one box, and 12 in another box. Okay, so 6 and 4 works. 1 and 24 works. 8 and 3 works. And 12 and 2. So these are all factors. And then I do 6 and 2 goes here. 3 and 2 works here. Wait, I'm sorry. Not 6 and 2, 6 and 1. 6 and 1. 3 and 2. I think I got all those factors. And then 12. I have 4 and 3. 12 and 1. And then 6 and 2. So I'm going to look at these groups and I want to go find what's the biggest number that all of these groups have in common. So the biggest number is 6 in all of these groups that have in common. So you have to just be able to write down your factors. And you might have to Google factors of a number if you don't know them off the top of your head. 6, 6, and 6 is in both of these groups. So my greatest common factor for 12, 24, and 12, 6, and 24, the greatest common factor is 6. And that number can fluctuate, okay? It might be, let's say if I had a different number here. Let's say it was, 36. That number could change. So you just have to break down all the factors and then find the one that's the biggest that they all share in common. Alright, so let's try some problems together. It says solve the quadratic and which method should you use and why. So here, the method that I'm going to use to solve this is factoring. Is set equal to 0. Okay, so hold on, let me go back because I skipped the other part. So here, we know a solution, root, and 0 all means where the graph crossed the x-axis. And that's our x-intercept. And then the x box is a method used to solve quadratics. Okay, it's a method used to solve quadratics. And that's all our key vocab. Now let's go ahead and go to our practice problems. Okay. So if we look here, it says, solve the following quadratic and which method should you use and why? Well, it's already set equal to 0 for me. And I notice that I have a trinomial here. And I want to try to use factoring. Yes, we could go to completing a square, but factoring is faster if you can find the factors quicker. So here, since it's set equal to 0, I'm going to factor. Okay? And my factoring requires me to pick out A, which is 12, and it's always the number in front of x squared. B is negative 7, that's the number in front of x. And C is negative 10. So I have my A, my B, and my C. Okay, so I'm going to go to my X box. And if you remember from class, the X box says to be A times C in this box. So 12 times negative 10 in this box. Now, before I begin I need to look up here and make sure there is no greatest common factor. Because this X box only works when this quadratic is a prime quadratic. So the greatest common factor of 12, 7, 12, 7, and 10 is 1. So I can go ahead and start this. So I do 12 times negative 10, which is negative 120. And then I put B right up under here. And now I need to say, what are the factors of negative 120 that will add to give me, or that will sum to give me negative 7? So what are the factors of negative 120 that will sum to give me negative 7? So I am going to go grab my calculator because I need to go find these factors that will help me out here. So here we go. So you can either go to your PDF or you can go to Google. And then if you go to Google, you can type in Desmos Scientific Calculator. So that's what I'm going to do. Desmos Scientific Calculator. And then I'm going to click on there. And I'm going to go through and just start trying to find my factors. So I know that, first of all, I need to look and see. One of these numbers, I need to look. My number is negative. So one of my factors is going to have to be a negative number. So when you see that the number in the middle is a negative number, one of your factors have to be a negative number. So the negative, I need to find what are the factors of negative 120 that was summed to give me negative 7. So let's go play. So I know that I can do 10 times negative 12. That gives me negative 120. But if I do 10 plus negative 12, I get, oopsie, let me clear that up. I get negative 2. That doesn't work. Alright, so I gotta find something else. I know this ends in a 0, so I can do 120. Well, hold on, let me clear it. I could do negative 120 divided into 5, so I could try to find my factors. Oh my gosh. Negative 120 divided into 5 is a negative 24. So I can say, and that was for me to help find my factor. So I can say 5 and negative 24 is a factor of negative 120. So I'm going to say, well, negative 24 plus 5, does that help me out? Negative 24 plus 5, that's negative 19. So that's not giving me what I want. So what if I do negative 24? Let's see, let's go here. Negative 24. Didn't I just do that? Plus 5. That didn't work. And I'm trying to get this down to negative 7. So I got to go higher. So let's do 120 and see if it'll divide into 20. Oh, that might work. So 120 divided into 20 equals 6. So 6 and 12 are factors of 120. So I'm going to say 6 and 12. So I'm going to say 12 minus 6. Wait. $120 divided by 12. Oh my gosh, this is killing me with this decimals. Okay, so 120, and we was doing 20, right? Okay, 20 and 6 is a factor. So 20 times 20 minus 6, that gives us 14, so that don't work. And then what if I did negative 20 minus, plus 6, negative 20 plus 6 equals negative 14. So that's still not helping me out with my factors. So I still need to get negative 7. So I'm going to take a leap. I'm going to say 120 divided into 40. So that's 3. So that's too big. That's not going to work. So let me see if 330 will work. So this is how you guys can work through to find what you need. 120. That's still not big enough because I want to get negative 7. And 30 plus negative 4 is not going to give me negative 7. So I need to keep going. 120. What if I did 9? So 9's not working. Okay, let's do 120 divided by 6. So we get 20 and 6, but 20 minus 6 isn't negative 7. Okay, so what if I did 120 divide by, let's see, it won't do 25. Will it do 10, 12? Let's try 13. All right, so you see how we're trying to think, or if you're working with me and you're trying to think about it too. I know 6 will work. So guess what I'm going to do? I'm going to use my resources. I'm going to look and say factors of 1, factors of 120. Okay? So here are my factors of 120. Alright? And I'm looking for the one that I can work with that's going to give me negative 7. Okay, so I'm going to go down this list. Ooh, I found it. 8 and 15. So if you look here, I'm working with 8 and 15. So I'm going to go back to my calculator, and I know one of these numbers have to be negative. So I'm going to say 15 minus 8. Ooh, I'm almost there. So that means I need the 15 to be negative 15. Well, let me show you like this. 15 plus negative 8, that gives me 7. Then I get 15, negative 15 plus 8 equals negative 7. So I got it. So if you need to go and do the factors, because you saw as I kept going, I couldn't think of a number. You could have started with 2, 3, 4, 5, 6, 7, and kept dividing until you found one that worked. You could have did it that way too, or you just go look for the factors and then think about how you can add or subtract them. And remember, if this number is negative, one of your factors has to be negative. So in our case, our 15 had needed to be negative and our 8 had needed to be positive. So when I add negative 15 plus 8, I get negative 7. So I'm good. And then you have to put the A up under here. Now, once you put the A up under your two factors, we have to do one more thing to make sure we are good. So what we do is we have to go and reduce those fractions on the side. So we have to make sure those fractions are in their simplest form. So I'm going to go and say negative 15 over 12. I'm going to stick that in decimals just in case you can't remember how to simplify fractions. So negative 15 and then 12 goes to the bottom. Flip to your ABC key. You get negative 5 over 4. So here, I'm going to redo my X box. This becomes negative 5 over 4. And 8 over 12. I'm going to go stick that in. And you get 2 over 3. So here on my sides is 2 over 3. And this is all I need to worry about for my answer. So now I get x minus 5 over 4. And x minus 2 over 3. Now, I need to rewrite this because that 4 can't stay as a fraction. So I'm going to slide it to the front. And then, oh, that's not a negative. This is plus. So I'm going to plus it right here. And then we get the 2 to stay. So we factored this, and now it equals to 0. So I factored it down, and the problem says, what are the roots? Solutions, x-intercepts are 0. So I'm going to take that factor that I have down there, 4x minus 5 times 3x plus 2 equals 0. Okay, so I'm going to take each one of these factors and set them equal to 0. So 4x minus 5 equals 0. I'm going to use my line method, do my math. Divide by 4, divide by 4. And I get x equals 5 over 4. That's for that part. And then I get 3x plus 2. I have to set it equal to 0. Minus 2, minus 2. 3x equals negative 2. Divide by 3. Divide by 3. X equals negative 2 over 3. Okay? And then we got our zeros. So here, we're going to go and answer the question now. So we know what the zeros are. And now I'm going to go up here and answer the question. So I got x equals 5 over 4. And x equals negative 2 over 3. And then I'm going to go here and say, will these roots cross the x-axis and why? I'm going to erase this so I have room. Will these roots cross the x-axis? And we're going to say why. We're going to say yes. There is no I. Or you can say these are real roots. and we're finished. All right, let's go to the next one. It says solve the quadratic, and which method would you use? Okay, so if I'm dealing with this one, I need to solve this quadratic, and then I need to decide which method I'm going to use. Well, it's set equal to 0, so I'm just going to go with factoring, because I could go with completing the square, but I know factoring is going to be faster. So the first thing I want to pull out of here, I'm going to look at these numbers and determine if they have a greatest common factor in them. So I'm going to go down here. The factors of 9 are 9 and 3 and 3. So if I did my GCF right quick, and you'll get fast at this and do it in your head. You won't need to make this chart, but I'm doing it just for your sake so you can see what my thinking is and a way you could possibly think about it. So the factors of this are 9 and 1 and 3 and 3. And if you need to go to Google and look at the factor chart right quick, that's fine too. I know the factors of 30 are 1 and 30, 10 and 3, 15 and 2. I don't think I forgot any. I think that's all of them. Oh, wait. 6 and 5. And then the factors of 39 are 1 and 39. And I know it's going to be 3 too. I think it's 3 and 13. And you can always go and check to make sure you have all the numbers with this situation. And I am going to go check. I'm going to make sure I have all my GCFs for 39. So I'm going to go here to this and type in factors of 39. Just to make sure I got my list right. Okay. So factors of 39 are 139. So 1, 3, 13, and 39. So I got all of those. So 1, 3, 13, 39. Okay. So I got all the factors, and I know I got all of them for 30. 39 is not a number I work with as often. So I'm looking for the biggest number that they have in common, which is, it looks like the biggest number they have in common is 3. All right. So when I get that GCF out of there, I'm going to go here and factor out the 3. So if I take 3, if 3 is one of the factors, what is the other factor that I have paired with 3? That's 3. So if I take 3 out, I'm left with a 3 inside the parentheses and keep the minus sign. If I take 3 out, that was paired with 13. And I keep that. And if I take 3 out here, that was paired with 10. And it's still set equal to 0. So now I have this where it's factored down. I have it where it's factored down, and I'm going to use my X box now. So I need to go and identify my A, B, and C so I can factor this. My A, which is the number in front of X squared, is 3. My B, which is the number in front of X, don't forget the sign, negative 13. And my C is negative 10. All right. So from here, I'm going to snap my X box on there and make it go. Okay, 3 times negative 10 is negative 30. The B goes right up under here. And then on the sides, you need the factors. So you need, what are the factors of negative 30 that will add to give me, that will sum to give me negative 13. So those I know off the top of my head. I know one of them have to be a negative number. Hold on, let me make sure I did that right. Oh, wait just 1 minute. I don't think this one's factorable. Okay, so I know that one of those numbers need to be, I need a negative 13. Because if I was doing 10 and 3, they would, both of those numbers need to be negative for this to work. Okay, let me go back and change the problem. I'm going to make this a positive 30 so that this problem would work. Because there are no factors of 30, it wouldn't be factorable. Oh, I'm lying. It is factorable. Hold on, I'm tripping. Okay, so I know one of my numbers have to be a negative number in order for me to get negative 13. So of all the factors that I have of 30, and I got lucky they were already here, you could have looked online too. 15 and 2, that's how I figured it out. 15 and 2 are going to be factors, but in order for this to be negative 13 when I add them, or when I get their sum, I need negative 15 plus 2 to work here. I need negative 15 plus 2 will give me negative 13. So here I'm going to put the A up under each one of these terms. And then, you have to go to your calculator and make sure these are reduced. So I'm going to draw me another little X box for my reduction. And negative 15 over 3 reduces to negative 5. And then 2 over 3 does not reduce. And you can use Desmos to check that out. So the answer to this question ends up being x minus 5 and x plus 2 over 3, but we know we're not going to leave those fractions, so we're going to slide that 3 in the front, 3x plus 2. Now, since we had a greatest common factor on the outside, which is this piece right here, don't forget to tag it along. So that's the factored form of that. So we're going to go up here, and we're going to say 3, and then we get x minus 5, and then we have 3x plus 2 equals 0. Okay, we're going to set each one of these factors equal to 0. So 3 equals 0, no such thing as an answer. And then we have x minus 5 equals 0. We can solve that. That's a pretty easy one. X equals 5. And then we have 3x plus 2 equals 0. Use our line method, solve that equation. And we get 3x equals negative 2 over 3 over 3. X equals negative 2 over 3. I found a way to find the answers. Okay, and then you guys might pick it up. I'm not going to tell you. You might can figure this out on your own. There's a quicker way. All right, so we get the x-intercepts for this question is, after we've done all that work, and we're going to go here and write what the answer is. So x equals negative 5. I mean, not negative 5. X equals positive 5. And x equals negative 2 over 3. And y'all, there's a shortcut. I wonder if you guys notice it. I'm not going to tell it to you. You might pick it up. Okay, where the roots cross the x-axis and y, we're going to say yes, because these are real numbers. Okay? And we're done with that problem. I'm going to go see something. You guys, there may be a pattern in the next one too. Yep, I think you guys are, you might pick up on the pattern. You can actually get rid of a step in this problem. Okay, so I want you guys to try the next two homework problems, and I might end up telling it to you. But there is actually a step you can cut out in this problem to help you get to the answer. And you might pick up on it, and I'm going to give you a hint. It's right here in the box. You might be able to pick up on it right here in the box. If not, then just keep going the way that I taught you. All right, talk to you guys in class.